Everyone, and welcome to today's webinar. Thermo Scientific PGNAA technology for coal mining and loading applications. My name is Cici, and I am the vertical marketing manager for the Thermo Fisher. Today, I will be your host for this event. We are excited to bring you today's event, sponsored by Thermo Fisher Scientific. Thermo Fisher supplies innovative solutions for the world's industrial market, with applications that span coal, mineral, mining, coal-fired power plants, and other heavy industries. We provide a broad range of products and services designed to meet your tough analytical challenges. And now I would like to introduce today's presenter. We are pleased to be joined by Kevin Gordon, Global Marketing Manager, PGNAA, and Jeff Morton, Regional Sales Manager, Bulk Material Handling, Bulk Weighing and Monitoring. Kevin has more than 20 years experience in both core applications and the PGNAA product line. Kevin specializes in implementation of online process control to enhance the process to improve efficiency and maximize control cost. Maximize cost control. With experience in several different industries from all over the globe, experience allows us for a unique perspective in the implementation of real-time online analysis. Jeff is Bulk Material Handling Regional Sales Manager in Australia and New Zealand. Jeff has more than 10 years experience in mining and a total about 20 years working experience in engineering. Jeff, thank you for joining the webinar today. And Jeff will start today's sessions by introducing a bulk material handling solution in coal mines. We are here to have you. Please feel free to get us started once you are ready.
Firstly, thank you for joining with us today. And all I'm going to do for the first 5 to 10 minutes is just to give a brief outline of BMH, bulk material handling for Thermo Fisher Scientific in the coal mining, coal ship loadouts, and how that works in the world for you. I just wanted to remind us, we've been doing this now for 67 years. I think that's a good thing to keep in mind when you're dealing with Thermo Fisher. There's not too much that we haven't seen. There's not too much that we haven't had a go at. And we are quite good at saying, yes, we can do it. And we've got that good 67 years of experience behind us. I wanted to show you this slide before we really get in, just to show you the global manufacturing footprint that Thermo Fisher has around the world. So it doesn't matter whether you're on the other side of the world from Australia right the way over in America or Asia or Europe, we have manufacturing plants that can build this equipment and get it to you, I think, reasonably well and reasonably quickly. So hopefully today we'll look at these three things. We're going to look at tramp metal detectors, belt scales, if we get time, conveyor switches, and nuclear density. That'll be the short goal. One of the most important bits of equipment that we're selling in Australia and then throughout the world that we manufacture is our tramp metal detectors. Now these are really only are going to do two things. They're an insurance policy. They're a cheap insurance policy. They're either looking after your crusher. If you're at the mine, they're looking after your belt for belt rips. I had an interesting experience not too long ago where a bucket tooth got lost from a bucket that weighed 140 kilo that ended up through the crusher and then ended up on the customer's conveyor belt. So all the metal detector is going to do is look for metal on your belt and trip a relay and stop. So we're going to protect your crusher, we're going to protect your pulverizer, we're trying to stop any of those jagged rock bolts or steel bolts ripping into your belt, or quite often here in Australia, we are trying to stop the metal getting onto the ships at the ship loaders. We've found quite a bit of a market in BHP Western Australia where we put these on the pile reclaimers, on those great big bucket reclaimers. So if they do lose a tooth on that, it's not getting put onto the conveyor. So very useful bit of equipment, very cost effective compared to the price of a crusher. You got a $25,000 Australia piece of equipment protecting a $300,000 crusher. We sell quite a lot of these around the world. Very good, useful bit of equipment. And if you can see from that little diagram there, the metal detector is going to do, it'll either stop the belt, it'll drop a flag on the belt so someone can find where the metal is, it'll send off an alarm, it'll trip a divert chute. All we're going to do is trip a relay, and then it's up to the customer's imagination. What do they want to do at that point? Stop, divert, catch, boost the magnet, you choose. That's what we can do. Good bit of equipment. One of the other things that we sell quite a bit into the coal industry is just a simple density gauge. And we could use these in the thickener underflow. We can use these in cyclones. We use these in process control, plant balance. There's a number of things. 99% of the time we use a cesium 137 nuclide. Every now and again we use a cobalt, but most times we use cesium. Happy for any questions on this. This one we only manufacture in Adelaide, Australia, and we send it all around the world. Doesn't matter. Doesn't matter the application. Whether it's food, whether it's coal, whether it's petrochemical, whether it's paper and pulp, sewage, water treatment, all these things we can do. It's a very useful, very robust piece of equipment. One of the things that they do in bulk handling a lot around the world, and this is the one that we started 67 years ago, is our conveyor systems. Whether you're in a quarry and you need a 1% accuracy, or whether you're actually on a ship loadout, loading your ship, and you want that 0.25% accuracy, that's where we can use that top left-hand corner 1014 scale. NMI in Australia, NTP I think it is in America. And the great things about these sort of scales, and I noticed there's some people on this webinar from Indonesia who've got more experience in this than I have, is we can prove it. And we prove it over and over again, either against a truckway bridge, which has got a load cells 4 times more accurate than our sort of scales, or against a hopper on the truckway bridge or the hopper on the load cells. We can actually prove the accuracy and the repeatability and the reliability of these scales, which is a good thing. And it means in the long term, you're either not giving your customer too much ore, or you're not losing money, all from these sort of scales. Still make them in Adelaide, still make them in America, still make them in Italy, I think. We still make these in Europe, all around the world. Very good, very useful, very solid. That one there is a special one. If anyone ever wants specific information on how we do the NMI, how we do the NTEP, more than happy to answer those questions, more than happy to help if I can. Because we are looking at metal detectors on conveyor belts, we look at belt scales and weightmeters on conveyor belts, and because in a moment Kevin's going to be speaking about some of our equipment that can go on a conveyor belt, it was just only natural that we would produce and manufacture our own series of runoff switches and safety pull switches and tripper position switches. And unlike a lot of these around the world, ours is still made out of a die-cast steel / aluminium. Robust, especially in hard rock applications. I'm not quite sure how many millions of these we sell a year, but we do sell a lot. And so all that is just a very brief snapshot of BMH in this world. And on that note, I'm going to hand over to our main presenter, Mr. Kevin Gordon. Thank you, Kevin. Thank you, CC.
Well, thanks everyone for joining today. I hope everyone is staying safe and well out there in these difficult and interesting times throughout the world. So this gives us an opportunity to reach out to you guys when we can't come and visit you in person, which as some of my colleagues know, they know I like to travel. So I like to see you guys, but this will have to do for now. So what I'm going to talk about is the Thermo Fisher solutions for coal mines and ports utilizing the PGNAA coal analyzer technology. If you think about coal mines and port applications, you're actually a coal producer, right? So you're producing a product. And whenever you produce a product, It has various materials that you have to utilize to create what type of product you're looking to create. So, that's the same thing in coal. So we'll go over a little bit about the PGNA technology and how you can use that in coal mines and in port applications to produce the correct product that your customers are requesting from you. The first slide talks about quality control versus process control. And I use this slide in just about every presentation that I give because I think it's that important to understand the actual benefit and use of the coal analyzer. So if you're not familiar with our offerings just yet, you will be at the end of the presentation, but in the right-hand corner is our Thermo Scientific ECA3. It's one of our cross-belt analyzers specifically designed for coal. And in the left-hand side is one of our laboratory equipments, XRF, in which you can get a sample and get put a sample into the analyzer and get an analysis. But these are obviously two different pieces of equipment, but they both do analysis, but the analysis is very different in terms of how they're done. So I'm going to actually read this slide from verbatim, and I usually don't do this, but I think these sentences are really good and very important to understand. Quality control is a system of maintaining standards in manufactured products by testing a sample of the output against the specification. So that's basically what the laboratory analyzer would be used for. So how would that work at a coal mine? So let's say a coal mine is loading a train to send to one of their customers. They have a specification on moisture, ash, sulfur, and calorific value. So during the process of loading that train, samples would be taken, and then that sample would be sent to the laboratory, and that would be tested against the output against the specification, right? Because you're trying to meet the specification from your customers. But process control is instrumentation that ensures consistency. Measurements are one of the most important parts in a processing plant. Using the proper process control instrumentation, in this case, the PGNA analyzers, to remodel and rework your internal operations allows your machines to reduce variability and run to the best of their abilities. So if we think about the process of loading that train, the analyzer would monitor the coal quality going into the train, 10,000 tons or what have you, on a real-time, minute-by-minute basis. So that is going to allow you to control your process to ensure that you meet the specification. And then again, the quality control is going to just test the output against that specification. So they both do analysis, but their impact are completely different. So the analyzers should be used in a process control situation. Now, the questions may arise, well, what does that mean for a coal mine? Well, I've got some examples that I'm going to show you of different customers and how they utilize the PGNAA technology. So what is the PGNAA technology? Well, it stands for Prompt Gamma Neutron Activation Analysis. And the way that works is basically a thermal neutron, whether it's a californium-252 radioactive source or a actual electrically driven neutron generator to produce neutrons. Basically, the neutron interacts with the nucleus. And when it impacts that nucleus, it gets excited. The nucleus becomes excited. But very, very quickly, it wants to go back to a stable state. So what it does is gives off a gamma ray. That gamma ray is then read in from our detectors that are inside the analyzers, and it creates a spectrum. Now, each spectrum or each element within that spectrum has what we call its own fingerprint, okay? So a spectrum runs from basically a mega electron volt 0 to 512. And for instance, the element chlorine is at 275. So each different channel is to where those elements are. And those are the fingerprints. And then based upon the peak of that spectrum at each of those levels, we can determine how much iron is in the sample, how much calcium, silica, etc. That's the fundamental basis of PGNAA analysis. At Thermo Fisher, we offer two different types of PGNA analyzers for the coal industry. In the top right-hand corner is our Thermo Scientific CQM Flex. It is a sample stream analyzer. So if you think about the example that I talked about where we would collect samples for this 10,000 ton train, that sampler would actually feed coal into the CQM Flex, and then the analyzer would control all the material through the analysis zone and therefore give you an analysis. In the bottom right-hand corner is the ECA3 that I mentioned earlier. It sits directly over the conveyor belt. Now, you may ask, well, why does Thermo Fisher offer two different analyzers? Well, quite frankly, the CQM Flex is the most accurate analyzer in the industry in terms of coal because it controls the coal through the analyzer in a solid geometric shape. If you look in the back, you've got the hopper in which the sampler actually feeds coal into. And then the CQM Flex has a variable speed drive to control that coal profile. Now, that's important because with any PGNA analyzer, it's very important that you have a consistent neutron flux. Well, the neutron flux, and I'm no physicist, but the neutron flux is a fancy word for background to signal ratio. So you want as less background as you can and more signal. Well, when the coal volume changes on a crawl spout analyzer, that neutron flux can change, and that can cause some adverse situations to the analysis. Now, there are compensation things that you can do, and we do that to compensate for those inaccuracies in belt loading. But whenever you compensate for something, you're also just compensating for some error. The CQM Flex controls all of that. I like to think about the ECA and the CQM Flex as two different tools to do different jobs. And with the ECA3, I like to think of it more as a sorting analyzer. So if you're bringing coal from the mine and it may have variations in ash or sulfur, then you can sort with the ECA3 and put a low ash pile and make a high ash pile or a low sulfur pile, et cetera. The CQM is better for blending because when you do want to create that final product, it's important to get as close to that specification as possible. So again, this next slide just kind of details kind of what I talked about a little bit earlier. Both analyzers can measure moisture. The moisture meter actually comes integrated in the CQM Flex. And on the ECA3, it's an option that would be a standalone unit. When it comes to accuracy, you put the ECA3 into the correct application. And when I say correct application is you've got a good belt size, you've got good belt loading, the top size of the material is consistent, then the ECA3 in terms of accuracy can rival the CQM Flex. But in those cases, you can probably think that the ECA3 is about 20% worse in accuracy for the CQM Flex. So it depends on kind of what your application and the accuracy that you need in regards to that application. One key thing about the CQM Flex, however, is it can use either a californium source to produce neutrons or a neutron generator. Now, the positive things about using a neutron generator is it gives us the ability to measure carbon and oxygen. And with carbon and oxygen, you can get a calorific value measurement without using some assumed values. Now, the key to getting carbon and oxygen measurement is that you have high energy neutrons. So a neutron generator outputs neutrons at 14 MeV compared to californium, which only emits at 2.1 MeV, okay? So the engine has 7 times greater neutron power, if you will, in terms of energy than californium. That allows the activation of carbon and oxygen, and therefore we can produce those analysis with an engine in the CQM Flex. The ECA3 only has a californium option. So in terms of what the CQM Flex measures and reports, total moisture, total ash, but we sum the ash oxides, and that's iron, silica, calcium, aluminum, potassium, titanium, and in some cases sodium. Generally, the sodium needs to be 0.2% of coal or greater for us to be able to detect it. You can detect it at lower levels, but the accuracy is not really there. And it has a lot of noise on the signal, if you will. So generally, sodium has to be 0.2% of the coal or greater. Other elements are sulfur, nitrogen, chlorine, carbon, hydrogen, and oxygen. And if you see the asterisk at the bottom, it's really only with the neutron generator option that we can offer the carbon and oxygen measurements as well as hydrogen. Calorific value, and then fixed carbon and volatile matter. Again, that needs the carbon and oxygen measurement. So that would be with the neutron generator option as well. The ECA3 doesn't have all of the capabilities that the CQM Flex has, but it can still measure the total ash and the total moisture and the sulfur. Generally, anything but the carbon and oxygen because of the neutron generators situation. And then down below is how we would calculate the calorific value with an ECA using the moisture measurement as well as the as received ash measurement. But in this case, we also have to assume a MAF CV, which that MAF stands for moisture ash free. So basically, what is the heating value if there were no moisture or ash? So we enter that into the computer, then we measure the moisture and ash and provide the calorific value measurement. So, I truly believe with any product, software is kind of like the bow on the present, right? So the analyzer is doing its thing in the field, but how do you get the analysis? How do you use the analysis? What does an analysis mean? Well, one of our key software packages is called COBOS. It stands for Coal Blending Optimization System. And what this can do is can automatically blend your coal to up to 3 control parameters. So when we think about the example of that train that we mentioned about earlier, and we talk about the specifications that a coal mine needs to meet to their customer, whether that's going to a power plant or a steel plant, generally those specifications are more than one, right? So you have to hit an ash target, you have to hit a sulfur target, a calorific value target, and sometimes even a moisture target. Well, COBOS can basically control up to 3 of those. So you can go into COBOS and say, okay, sulfur is 1%, calorific value is 5,000 kilocalories per kilogram. And then you tell COBOS what your sources are. So if you look in the left-hand corner, this example is showing low BTU feeder, a high sulfur feeder, low sulfur, and a high BTU. So you tell COBOS that I have these sources available and this coal quality available. And then based upon the analyzer's analysis and the specifications that you have put in terms of your targets, the analyzer is going to blend, or COBOS is going to blend all of those coals to that specification. Okay. One of the great things about COBOS, though, is with each source, you put a dollar value on it. Okay. So maybe it doesn't have to be very precise. You could just say the cheapest coal that you have, maybe $1, and then $2, $3, $4. And COBOS is going to try to use that lower dollar value as much as possible, but still get to its target. So this software is really good to kind of, really wrap up the analyzer's analysis and really make that analysis really dynamic. So we've talked about, the PGNAA technology, kind of showed you what the analyzer can do in terms of analysis with the CQM and the ECA. But what does that really mean and how can you really use it? Well, after this slide, we're going to get into some real world examples. But first of all, at the mine, the ability to sort different quality coals. So mines can have different seams, whether you're a surface mine or a deep mine, they can have different seams. So you're going to maybe pull some part of the mine and you're going to get a high ash or a low ash or a high sulfur pocket, things like that. Well, think about you put an ECA on the output of the mine, and you can sort those coals in real time and create different piles. And when you create those different piles, you can always blend those back in. And that goes to that one of the bullet points in the middle where it talks about maximizing the use of lower quality coals. So, a high ash coal is going to be cheaper than a lower ash coal, or a high sulfur coal is going to be cheaper than a lower sulfur coal. But you still want to be able to maximize that, because if you think about the coal mine, what's the most valuable resource that a coal mine has? Well, it's the coal. So you want to maximize as much of it as you possibly can. So some of the examples at a cleaning plant, depending on where you're at in the world, sometimes, you don't have a cleaning plant. Maybe it's all raw coal. But in regions that do, you can get greater yield and recovery. You can bypass the cleaning plant. We actually have an example of that. We'll get into here in a bit. So once you've mined it, once you've cleaned it, well, then you have to ship it out. And that's where the contract specifications come in to play. And that's where you can blend the lower cost coals, but still meet your specification. And that's going to result in a consistent quality. We go back to when we talked about process control, it's about consistent quality and producing consistent quality. And that's where the analyzers can benefit. And then obviously fewer penalties from out of spec shipment. Sometimes if you ship an order out and the quality is not what was specified, you can get penalties. I've even seen cases when the coal is actually even returned to the producer. So when we talk about sorting coals, here's an example. This was a U.S.-based company that sent trucks to different places based upon the quality of the coal. And this was based upon two things, so ash and sulfur. But the thing here is the trucks would go 60 kilometers to the west or 60 kilometers to the east solely based upon the analysis. And if they went to the wrong place, there would be penalties. So this customer installed an ECA analyzer directly from the mine so they knew what coals that they were getting. Now, this was a 3-minute analysis. So the analyzer only saw the coal for 3 minutes. And they were able to tell the truck driver, if you look in the bottom right-hand corner, it basically said section C was to go to 1 part based upon the sulfur content, and then section, I think it was A or B, to a different one. And if you look in the bottom right-hand corner, they have a high sulfur limit and a high ash limit. And they were basically able to reduce contract penalties just by knowing where the coal was going to be. This next example is from a preparation plant in which they mined all of their coal, but the mine was so large they really didn't know the quality that was coming into the plant. And I'm not sure how the audience is really familiar with coal preparation plants, but to wash the coal, they changed the specific gravity within the plants. And when you change the gravity, coal floats, rock sinks. But that was not their philosophy. They wanted to keep a steady gravity and then be able to utilize any kind of coal that was made. But they didn't know what was coming in. So you can see some of the logistics here. The analyzer was put on the output of the preparation plant. And on a real-time basis, it was able to sort to 4 different stockpiles. So they were able to basically utilize more coal coming from the mine than they had previously. Their business case to make this type of investment was only 1% increase in yield. So if you think about a 1% increase, that doesn't sound like a whole lot in our minds. It's just 1. But when you think about the amount of tons that they do, that obviously becomes significant thing. So the business case was 1, and post-analyzer, they actually made just about 3% overall recovery. So that was money that they were able to recover that in the past they basically just gave away. So the investment was very good and very critical for them. So we've talked about a couple of sorting examples, and now this one is a blending example. So in the top picture, you can see 2 stacking tubes, and in the far background is actually 2 silos. So this customer has 4 different qualities of coals that they would put into the 2 silos and the stacking tubes. And they used a CQM at the loadout that you see in the bottom picture. The CQM is within that loadout. But they also utilized Cobos. So if you remember, Cobos is our automatic blending software. Well, they used 2 control parameters, ash and sulfur. And you can see in the graphs that the target that they put into Cobos in the red, and the blue is the actual analysis from the analyzer of what Cobos actually did. So you can see that Cobos really hit its targets just about all the time. You'll see two examples on the sulfur graph in the bottom right-hand corner. You can see the target for sulfur for two of those trains was 1.8%, and the actual was around 0.8. Well, the reason why is they did not have that high sulfur coal to be able to get to that point, right? So that's an interesting thing to understand about Cobos is you can set a target, but you've also got to make sure that you have the coal to be able to hit those targets. So in this case, they didn't have the high sulfur, which was okay with them. So they just kind of blended with the lower stuff. But this is an example of how well Cobos can hit the target. So if you think about it, it's automatic blending. Cobos controls the feeder percentages and things like that. And it's really good. So earlier we talked about, at the preparation plant, bypassing the coal from the mine. So in this particular example, the coal coming from the mine in spurts was at the ash level that the customer wanted already. So in order to save cleaning dollars, to save cost into actually cleaning the plant, they put in a CQM to bypass the preparation plant because there was no need to clean it. So this had a lot of savings in just in regards to like water use and energy use within the preparation plant. So it's really site by site. Every site's going to have a different issue more than likely. Every site's going to have different application things that the analyzer can help with. But these are just some of the examples that we have. This is, I think, the last example of actual customers. This is a site in West Virginia. They utilize both analyzers, actually. So if you recall the example that we showed that was sorting coals outside of the preparation plant, well, the ECA on the right-hand side of the screen, that's exactly what it does. So they make about 3 different products at this mine. They actually make a metallurgical coal, they make a steam coal, and they make a what they call a middlings coal. And the ECA is used on the output of the preparation plant to sort those coals. I think they put it in about 4 different stockpiles, if I remember correctly. And then on the left-hand side is at the loadout, and you can see the CQM there. This was obviously early on in the phase of the construction, but the CQM is there to blend all 4 of those coals back together. And this is a loadout tower where they used to do about 10 trains a week, I think. And then they would blend all that material. And if you think about that middlings product that I mentioned, that's about a 25% ash coal. And in the US, that's not really a high dollar coal at all. But they would actually take that and blend it in with a 7-8 ash product to get a 10. So if you think about selling a 25% ash coal for the value of a 10% ash coal, that's good savings there. So this is, I believe, the last slide, and then we're going to jump into some questions. But this is a very, very important slide. When we offer an analyzer to a customer, we always provide a performance guarantee. And that performance guarantee comes in a way of RMSD, root mean standard deviation. So that's basically the system accuracy. So when we talk about system accuracy, it's the analyzer error, it's the sampling error, and it's also the laboratory error, because there's error in all of that. But it's important to understand the system accuracy to be able to use that number that you're getting for the analyzer to hit whatever target you're trying to hit. So in this case, you've got an upper limit of 11% ash. And it shows the difference between 2 RMSDs. Obviously, the lower the RMSD is, the better. So in the first example, the RMSD is 0.35. And when you do the math, it basically tells you to put the set point at 10.42 ash. So if I had the analyzer and it was analyzing the coal going into the train, I would have the analyzer or have Cobos blend to a 10.42. That assures me that I won't go over the upper limit more so than 2.5% of the time. Yeah. The other example is 0.5. And in this case, you put the set point at 10.18 to ensure you don't go over 11 more than 2.5% of the time. But what does that mean? So a 0.35 and a 0.5 in our minds is a difference of just 0.15, but maybe it doesn't mean that much. But when we put the numbers together and we assume that it's 4 million tons per year clean coal sold, and the difference between those coals are $4 a ton, and there's a $10 ton variable cost of mining, the annual savings in just the difference between a 0.35 and a 0.5 would be $465,000 per year. So how do you use these numbers? I like to show customers this when they're on the fence about, are they interested in the CQM Flex or are they interested in the ECA? Because you can think of the 0.35 RMSD as the accuracy of a CQM Flex, and then the 0.5 RMSD is the accuracy of an ECA3. Remember, I told you it's about 20% improvement from a CQM Flex to an ECA, if the ECA is in the right application with the belt loading. So the CQM Flex is obviously going to be more expensive, but you can factor in the savings that you can get from an example like this and make a decision based upon that.
Okay, thank you, Kevin. It looks like we are out of time. I want to thank you all the audience for the fantastic questions and the participants. And if you have any question, please visit us at thermofisher.com/call. Thank you everybody for your time. This now concludes this webinar. Thank you everybody.